This is geometry, working on Unit 9, quiz number 2 review. We're looking at our different terms that go with a circle. So point F, I gotta find point F. That is a point of tangency. Angle FHG. FHG has the H at the center, so that's a central angle. EBD has the vertex at the edge of the circle, so that's an inscribed angle. HG goes from the center to the edge, so that is a radius. DB goes from edge of the circle to edge of the circle but does not touch the center. It's just a chord. Point C is the center of this circle. BD is a diameter. If you notice, there's no arrows. They're just talking from B to E. It's a special chord called a diameter because it's a chord that includes the center. DB is a line. It continues. So that's going to be considered our secant. And AG is a tangent. You could call it a common tangent if you wanted to get detailed, because it's being shared by two circles at the same time. Okay, so if you have to pause this, go back and try some of those on your own. Cover up the answers, see what you think. Okay? In our diagram, BC is a radius. We have to determine if AB is a tangent. Well, it says 90. I guess it would be a tangent. End of story. But let's show that it's supposed to be equal, not just because of the 90. What we're going to look at is AC, and we're going to compare that with the two legs, with BC squared and with AB squared. It's kind of, we're talking about hypotenuse squared equals leg squared plus leg squared. But if it's not a 90-degree angle, then it's not a hypotenuse. So I don't want to call it a hypotenuse yet. That's 85, and we're going to compare that with 51 squared and 68 squared. So let's get our calculator. Those are pretty big numbers. So we have 85, and we'll square that. We have 51, we'll square that. So we have 7225, and we're comparing that with 2601. And 68 squared is 6424. So I'm going to add these two together. So to make life easy, we'll take our 2601 and add it to our previous answer. And that gives us 7225. Those are equal to each other. Equal. This shows angle B is a right angle. Angle B is a right angle, okay, which makes it a tangent. So AB is a tangent. That was the actual question they were asking. Is it a tangent? So I figured out if I had 90 degrees there. I figured out if I truly had a right angle. Now, oddly enough, they gave us the picture. They told us it was a right angle. That was kind of more of a mistake. It's not a great picture to have used. But anyway, they used it, and we were able to show it. Coming down to 11. In the diagram, assume the segments are tangents. So AB is going to be a tangent, so we're not worried about is it. What we're trying to figure out is what is the radius. 32 goes from the edge of the circle to point A. So what we're doing here is the hypotenuse, which is x and 32. Don't call that 32x. X plus 32 is not 32 times x. And that's going to equal your leg plus your leg squared. Each one has to be squared. So how do we do a binomial that's being squared? You have to write it twice. Needs to be written twice. And 56 squared is going to be 3136. Now, how do I work with this binomials that's being squared? Two sets of parentheses. It's called FOIL. First, we multiply the front. X times x is x squared. Then we do the outside. X times 32. Then we do the inside. X times 32 again. And then we do the last two, which is 32 times 32. And we get 1024. That's still going to equal x squared plus 3136. So, collecting our like terms, x squared plus 64x plus 1024. Now this is a normal algebra problem. We're going to subtract x squared. We're going to subtract 1024. So the x squareds cross out completely. And we get 64x to equal. I can come up and get our 3136 and subtract the one that we just used. Kind of a quick way to do it if you know your way around the calculator. And we get 2112. And I bet that that's divisible by 64. There it is. So when we divide, we get x equals 33. That's a tough one. It's probably the toughest thing we've got. All right? That's the toughest, maybe not the toughest rule, but it is the toughest process that we have when we have to write the parentheses twice and we have to FOIL it together and move our x squared across. Okay? All right, coming down here, we're trying to figure out the value of x and the value of y. I know my opposite angles. If a circle is or if a quadrilateral is inscribed in a circle. If a quadrilateral is inscribed, that means its vertices are on the edge. Then opposite angles are supplementary. There it is. That's our property that we would need to be able to use. So the opposite angles are going to add up to 180. So I'll subtract my 114. That's going to give me 66. That would be my y. Now, when I look over here for x, I have x and no angle is marked. So I'm not able to do it that way. I don't know what that angle is. I can't use opposite angles add up to 180. But I do notice that this angle is opening up and it's touching the edge of this arc. So I know that angle J is going to be half of 52 plus 80. It's going to be half of 132. 66. So that's the measurement. It's half the blue arc. So J is half the blue arc, so X is half is J. Right. Okay, so we're doing the same idea. I would encourage you to pause the video and go ahead and try this on your own. See what you can come up with. We're going to have to use some of these arcs out here. Maybe these two arcs help you find Y. These two arcs help you find X. So give that a try. The inscribed angle will equal half the intercepted arc. So Y is going to be half of the intercepted arc. The green is where the blue touches a circle. So that part of the circle is called the intercepted arc. So Y is going to be half of 108 plus 104. It's going to be half of 212. It's going to equal 106. That is what Y is going to equal. And then X is going to be half of what it comes down to. It comes down and it's going to touch 108 and 75. That's 183. So that's 91 and a half. On the flip side, we know we have some diameters. That means they go all the way across. We don't have to pretend, are they actually diameters? Determine whether the given arcs are minor, major, or semicircle, and figure out their measure. So we have arc NQ. Well, for us to figure out NQ, I need to know what this little one is. Right in there. That little one is going to be 180 total. Take away the parts I already know about. 180 minus the 81, that's going to give me 99, minus the 73, that's going to give me 26. So this is 26. This arc is going to be the same as a central angle. This arc is the same as a central angle. So this is a minor arc, and its measurement is 81 plus 26, 107. Number 15, MRP. MRP is 180. It's half the circle plus 26. So that is 206. That is a major arc because it is over 180. MNQ is half the circle. It's a semicircle. So it is 180 degrees. I'm looking for MR. Well, MR and RQ make the semicircle. RQ is 73 because it's the same as the central angle. So this is 180 minus 73. That should be 107. And that is a minor arc. PQ, 2 letters, minor arc. Don't even have to look at it. But PQ, P to Q, we already calculated that. That equals 26. That's a minor arc. MQ to N. MQ to N is everything but this arc. And this arc's the same as that angle, and that angle is the same as this angle. So that's 360 minus 73. That should be 287. And that's a major arc because it's bigger than 180. That's a lot, but it should be doable. You should be able to do that. So we come on down to number 20. We're looking for BC. Okay, we know that angle A is going to be half of the measure of arc of BC. The inscribed angle equals half of the arc. So the measure of angle, well, let's see. What do we know? We know 37 equals half of the arc. I can't take half the arc. I don't know what the arc is. So I'm going to times by 2 to bring it over here. And I get 74 is the measure of BC. 74 degrees. Double the angle to get the arc. Half of the arc is the inscribed angle, since the vertex is on the side of the circle. Over here, we know the central angle is 132. So the arc is also 132. The central angle has the vertex at the center. Here it was at the edge. This was 74 because it's going to be half. Here it's the same because it's a central angle. But angle A is going to be half. $132. We went through that before. That's 66. BAC. The measure of angle BAC is going to be half of 158. That's going to be 79 degrees. The inscribed angle is going to be half. The central angle is going to equal. The inscribed angle is going to be half. You got to watch, see the difference between an inscribed angle and a central angle. All right, I think there's a problem to number 23. But we're looking for angle BAC. What is this angle? Well, I have a semicircle, half the circle. This is a diameter. So I have 180 minus my 55. That's going to give me 125. This is 125. The measurement of angle BAC, or we call it angle A, equals half of 125. That should be 62.5. Now it also is asking for AD. But I don't know any information to help me figure out AD. I don't know angle C. It doesn't tell us. So that's unknown. Not enough info to determine the measure of AD. We can't take half. We can't add up because I don't know what this breaks into. It's 180 total, but I don't know what this one is. All right. So we move on. We know that angle T, or PTR, angle T equals half the big arc, PQR, plus the small arc, PR. Big arc minus, not plus, sorry, minus the small arc. So, I don't know what the big arc is. So that's going to be 360 minus the 114. That's 246. Now I can do the measurement of angle T equals half of 246 minus 114. It can be 132. And take half of that, and hey, this is our lucky number of the day, 66. So that's our angle out here would have to be 66. Now, where people make a mistake, a lot of people say that this angle is half of 114. Not true. So a lot of people say this angle is half of 246. Not true. It's not inside the circle. T is not on the edge of the circle. All right, coming over here. CBA, C to B to A. What's its measurement going to be? Well, this is a diameter. So this is called a semicircle. Which is 180. So angle B is going to be half of 180. It's going to equal 90. It's a right angle. And then arc AC. Nope. Can't find arc AC. We don't know any relationship between what these angles. We don't have the angle values. Not enough info to determine the measure of arc AC. Oh, no, I'm sorry. I thought that was AC. I take that back. My bad. Arc AC, that is an illegal way to name it. You're not supposed to name the arc with two letters to be a semicircle. So improper naming of that. You would need another point. So the measure of ADC, now we're making the headway, is 180 because that's a semicircle. You've got to use three letters to name a semicircle, not two. What is that? Okay, last one. If the hypotenuse of a triangle in question number 25, if the hypotenuse is 12.8, then what is the radius of the circle? Well, we know that the diameter equals twice the radius, 2 times the radius. We know the hypotenuse equals the diameter. So 12.8 equals 2r, divide by 12, we get 6.4 is our radius, half of the diameter. which is half of the hypotenuse. Good job. Good luck.